Hello, everybody. We will start in several minutes. Let's wait for people to join us. Okay, so stay tuned. Okay, hello again for everybody who joined us, and thank you for joining us to the SolidCAM webinar series. Today, I want to talk about angle head attachments and use it in SolidCAM and manufacturing, and how to create a attachment, how to use it, and which options we have in SolidCAM to support different machines and different angular heads. Okay. So first, we can see here the classic part, simple pipe. It's pretty long. If I measure it from side to side, is 550 millimeter. So it's really hard to machine this side on small CNC machines on medium. And especially if you want to machine it in precise position, so you don't want to disassemble it from the vices. To keep the orientation, you need to create very complex fixture for it. But we have other solution. You can buy, or maybe you already have an angle head attachment on your shop, so you can use SolidCAM and angle heads to machine this part in one single setup. So let's start from selecting our angular head. I will use the OMG website. Okay, it's nice manufacturer of angular heads attachments and more. I like it not because of the quality of the product, also because they very nicely share with us the 3D models of it. So you can easily download the model. So I can go to products, okay, and we go to this J series. We can find here all what we have, and for our job, I will select this ER35 maybe product. It's good, okay. Let's get it. What is important for us is to understand the data, what we get in the tool features. So first, the RPM limit. We have 4,000 RPM. The machine can have a 12,000 RPM limit, but this particular attachment have lower limit. A second, it's the rotation. So once we rotation clockwise the input of the shaft of the angular head, the output will be rotated counterclockwise. So it means we have to take it into account when you make a G-code. So if I want to rotate my tool CCW, I need to rotate the spindle CW and opposite. And the last one is the torque graph, and we can find here the limits of the machine, and we are talking about 32 kilogram Newton meter. It's what we can go, or 15 kilowatt. So we will save it and in our heads, and let's download the files. So I will download the first file, okay, and of course the shank. I'm using BT40. I will also download it to my hard disk. So the next step is much more easier. Let's open it in SolidWorks. Okay, go to my downloads, take these two files, and just open it directly from downloads. Okay. So let's take first the BT adapter. Okay. It's in zip file, so I have to extract it. Right. Okay, this is a BT adapter. Okay, nice. And the second is one packet. The holder. Okay, now I can create in SolidWorks assembly. I will make it in SolidWorks because it's much more user-friendly environment. It's a CAD system, a partial CAD system, what we are using as our base. So let's take the head and insert here the component what we have. Let's save it before. I will open a new folder on my desktop just to keep all the project in same folder. Okay, let's say Angular. Okay, and I keep in here the assembly. Let's save also the ER adapter. And do it in the same folder. Okay, and now I make an assembly. Go back to adapter and just add to assembly the component I have. Okay, and we will use mates just to adapt to each other. Okay. What is important here is to keep the rotation of the component, because it can rotate according to the scale you have on the real holder. Here I cannot see the scale, but if you open the assembly or your holder, you will see here the angle scale. So just keep to 0 position. I will take put it like a more let's put it parallel to this plane. Okay, and just keep it like this. Okay. I don't know exactly what's the scale here, so hard to see it. Oops, what happens? take a line, maybe it's not parallel, put it here. Okay, now it's good. It's fixed, not rotated, so I can continue to create a holder. So first thing what I will do, I will create a coordinate system here on top of the BT holder, in the same place where I have a coordinate system of the origin of my spindle nose to mount the tool on a spindle. So first, let's make a short sketch here, and I will put the direction of y-axis and direction of x-axis. It's enough to create coordinate system, and create the coordinate system, okay, in this point, and set the x-axis direction and y-axis direction. Okay. It's important to keep it in the center of the spindle and to keep the up. Okay, if you want to make it the real assembly on the spindle easy as possible. I will create a next coordinate system in the middle, in the connection point between two components. So I just will hide one of them. Okay, and put here the new coordinate system. I will copy here the same sketch, just project it to the. Okay, let's create a new one. Same origin, the x-axis and the x-axis and the y-axis here. No. This is an x-axis and the y-axis. Flip it. Yeah, it looks good. Additional coordinate system, but I want to create the coordinate system for the tool mounting. So it will be in the middle of holder. Okay, so let's create here the sketch and make the same. What's important in this coordinate system is the direction of z-axis, because it's like direction of the tool. Okay, so I will put here two lines and let's put it in the middle. Make it again. Okay, this is my origin and my x-axis will be up. Okay, and the y-axis will be here. And I will flip the y-axis to get z-axis in opposite direction. General, z-axis will represent for me the direction of the tool I will mount here. Okay. Okay, so let's show again all the components. That's it. And we have now everything done. I will save it. Okay, now I want to create a tool table and store there the angular head. So I'm going to make a go to SolidCAM, ToolKit, create a new library. Okay, it will be a tool assembly. Okay, so I will start directly from the assembly. Okay, here when I come to the tool table and my assembly is opened in SolidWorks window, I can go and create the tool directly from the CAD. So I don't need to save each component separately in STL format and import it after. I just can go directly here, make an input from CAD. Okay, it's also always ask me, okay, be sure your component and your assembly is opened in the CAD window. And okay, and now I'm just make a generate a milling tool. Okay. Here I see all components is directly imported. Okay. But what I want to do is just to take all of this, okay, and say it a unit holder. It's one holder. Okay. Now I'm going to take a cutter and change it to the holder. Okay? Because it's not cutter, it's real holder. We don't have a cutter here. Of course, if you have cutter, you can generate it together with the cutter. So what I have two components, the upper side and the lower side. What is important for me, you see the coordinate system of it is pretty strange. It's generated here. So let's define the coordinate systems. So the change coordinates reference coordinate system, I can go here and say him, okay, my coordinate system is system 1. Okay. So now the reference of the coordinate system is here. Okay. And for the second, okay, I make the coordinate system is system 2. Okay. So now I see this is my second reference coordinate system. Okay. And in general, I can continue from here. Okay. The coordinate system of the joint, I will care about it after. So let's make an OK. Okay, it's okay. Let's go to advanced view. It's a good point. It's my fault. You need to make it in advanced view. So let's do it fast. This one is joint to holder, and this one will be a holder. I will make a coordinate system. This is first one, and this is the second one. And okay. Okay, what I see now, it's two components created here. Okay, if we go to the first one, this is what I'm going to see. Okay, first component joined here, and the second component is joined here. What I need to do now is just to add the cutting point for the last component. So it's joined for the last component, not in 0, 0 position. It's to go in to other position. I mean, here. Okay, and simplest way to do it is just go to the evaluate, measure, select different reference. I mean, the coordinate system number 2 for this one, and just pick on a point. Okay. So what I see here, something wrong here, to the point. Okay, so I see here it's in minus 70 millimeter in X and minus 76 in Z. So it's enough for me to know how to put my coordinate system. So I will edit my joint, what I have here. So it will be minus 70 and minus 76. Okay. Minus 76, of course, plus. Okay. And what is important for me, how I say it, we need to keep the z-axis in the direction of the tool. So I just need to rotate it around y-axis 90 degrees. Okay. Here's it. The holder is done. Of course, it takes some work to do it, but once you did it one time, you can save it. So I can save my tool assemblies, okay, as a OMG attachment, and save it in my toolkits. Okay, so let's start to use it. It's enough for me to create to start to work. So let's go to our part and make a first angular part that we started. So first, let's start SolidCAM, and I make a new milling part. Let's save it. Okay. and select the coordinate system. I will put my coordinate system in this place. So let's put the face, and I will make it here. Okay. Somewhere here is the place to measurement. You don't like it like this. There's something in SP2 of SolidWorks. Okay, let's pick an origin here. Yeah, cool. So here is the origin. I can rotate it maybe a little. Well, that's enough. Okay. The part is done with configuration. So I have two configurations for the CAM part. One is stock, one is a target part, and we can use it for stock definition. I will already add coordinate systems for the next operation. So I want to machine it here. Okay. I'll pick the origin here. Just make it easy. Okay. I want also to machine it from the second side. So I will add and select face and put it here. Okay, so we have coordinate systems defined. Let's define a stock. This is easy task. We will go to define by 3D model. Okay, I will switch to the stock configuration and just click on the part, switch back, and it's enough for me. Okay. Okay, we are done with everything. The easiest way to check if stock and target are correct, I just go to show 3D. I see my stock is unmachined. I see show 3D in of target. I see my stock is in machine stage. Okay. I can switch back to default configuration, but I want to machine and stay here. So what I'm going to do now is to machine the upper side, the upper feature. So let's make a milling. I will make a face. It's easy stuff. Okay. Select. Not. Let's make it by silhouette. No. Okay, have some geometry. I'm going to select the tool. So let's take a 12mm end mill. Okay. We can add some holder for it. I like to work in advanced view, so I can go to our holder database and like go to milling. I don't have, so let's go to HSK, whatever. Okay. Just for few, I have like HSK 60, AR32. That's one is good. Okay. Okay, nice. Everything is works. I don't need to fix it. Have a cutting, everything's nice. Okay. You have a toolpath. I will also add drilling. Okay. And select here just, I will copy the same tool to keep a holder. Okay, so I will copy and paste. I will hold the Alt key and drag a drill here. So it's exchange the item to drill. Okay, I will change it to 8 mm. Okay. And let's make a diff of the drill. Just go out here, make a full diameter, and just ensure it's go out about half millimeter additional. Okay, and the profile around. I'm not going to make a canvas and things like this, just to show how it works. Okay, so the profile. I will use the same 12 mm mill, okay, to machine it. And let's make a technology will finish, and in levels we will make 12 mm. Okay, so we did the first feature, okay, on this part. What I'm going to do now, I just going to select all of it with Control K and just drag it to the face. Sorry, it wasn't face. I will make it a little bit larger. Do not skip the face. Select all operations and drag it to the face. Okay, see what we have here. All operations is completely copied to this face. I'm going to do the same. This is the last one. Okay, just drag it here, and you get all operations done. What's the difference between this feature and this feature? And this feature, we want to make it with the angular head attachment. So first, let's see how it looks on the machine. I'm going to open the setup. Okay. Okay, let's move the part a little bit up. Okay, let's move it a little bit side. Okay, here's my part. Okay, I want to keep this orientation. Okay, I'm not talking about the pictures here, just how the part is positioned in the machine. Okay, so this feature, it's this side, yeah. So we maybe can rotate it in the CAD. I want to make with the head what's looking an X negative, and this side I will make with the head who looks an X positive. So let's back to the our toolkit. Okay, and I will copy this tool and change the holder for it, but the holder will be, this is the tool, yeah, I will take it from my assemblies, and what I get here in tool assemblies is OMG attachment, is what I created, and I have a holder here, so I will drag it here, and let's replace this one. I think we don't need it, so remove it from here. Okay, I will just put my tool. Let's have a cutter. Yep. And let's remove it and put it again. Okay, it's again about the advanced view. Okay, so we have its holder here, and I want to put a cutter here. Okay, so the cutter will be 12 mm, and you see the orientation of the cutter, it's the next negative direction, so it will be good for this side of the machine. Okay, I'll again copy this tool. Okay, This is number 3. Yeah. Let's copy and paste. And I will just change the tool, the cutter, to drill. So to change it, I am just hold the Alt key and drag the drill on this cutter. Okay. Now you see it's changed to drill. I just change it to 8mm diameter. Okay, and keep it like this. So I have new tools. The first one is the end mill, and second is the drill. Okay, so let's save and exit the tool tab. So of course, if I go into this operation, first thing what I will recognize when I open the machine preview is my coordinate system looks in strange colors, and also the machine position is wrong. So if you see coordinate system like this, it means SolidCAM cannot recognize how to make this operation because this tool cannot make operation from this side. So what I'm going to do now, I'm going to change the tool to a new one that we created, okay, number 3, and select. And now when I open my machine preview, you see the coordinate system gets the normal colors. It means we found the solution and the position of the tool it's correct. Okay, so I don't need to do nothing in this case. The tool path is already done. Just select this operation and change the tool number 5. Okay, number 5. Yes, to the drill. And now we have drills. And last thing what I have to do on this side is just change tool for the profile milling. Okay, so I'm going to tool and select the angular head attachment. Number 3 with 12mm end mill. Okay, so we are a programming part, and till now I didn't verify it if everything is going correctly. So first thing I'm going to do only for these two blocks of operations, I will run the SolidCAM simulator, okay, and let's see what we get inside. So first, we are not expected to something else. We have a good toolpath, and let's make it slower and run it for the first feature. After it, we get a face and drilling for the second feature. Everything is correct. Let's see what we have in machine simulator. Okay. Okay, have a part, drill. Okay, okay, and okay, everything is nice. It's done. Okay, of course we need to add some pictures and everything, but we have simulated toolpath. Okay, the biggest question is, okay, let's finish the third one just to be sure we have everything done. And go back again to ToolKit, just copy the tools I did, and for example, now I make this tool. I'm just making a copy. I'm going to this component of it, to the orientation of it, okay, to the connection point, and orient it here 180 degrees around Z. Okay, so let's keep it. And I will take a second one, make a copy of it, okay, and do the same. Okay, just rotate it 180 degrees around Z. So now I have rotated head. Okay. All what I need to do now is just to change tools for these operations. Go in and change the tools. Okay, be sure we are not the orientation of tool is correct, so we have to refer to this coordinate system. Okay. The drill. Number 7. And the last one is the profile. Okay, so we have here everything is done. So what we want to do now is to make a most important verification. What you can do is to generate G-code. Okay, so let's see how the G-code of angular head can look, and its looks in SolidCAM, and how it can look in SolidCAM. So first I have here G90 home position setting is not important, and all tools are set automatically. But first, before we are going, let's open the backplot. Okay, we see the toolpath, and we see everything is looks correctly. Yeah. If I go here to this arc, okay, let's open this one. Okay, what I can find here, this arc is done by K. So it works with J and K settings, and it's also in G90 set. So you can do it's use compensation. If you are making this arc on this side, you need to run with G32 compensation side. Okay, and if I use this side, of course the compensation should be different. So you can see here also it's used G41. So we take into account automatically all orientation and planes and everything. But what will happen if I will use or put my part in orientation, what's not exactly described, or the operations that I will get will be not exact in this case YZ plane. Okay, so let's try it. The easiest way to do it, okay, is just to go to setup, okay, and rotate it. I will rotate it 20 degrees around Z. Let's see how it looks like. Okay, and 20 is a little bit less. Let's make it 40. It's not rotation, sorry. Okay, let's go to advanced and rotate it 30 degrees, okay? So now the part is rotated, okay? So if I want to machine it, I need to do two things. First, I will not change it for all operation, only for the operations with arcs, this is the last one. I need to go to the tool, okay? Because this orientation of tool cannot make this operation, okay? And just add to the orientation, okay? So let's go to ToolKit and do it there. Okay. Okay, this is my tool, and I go here, and instead of 0 orientation around X, I will add here 30 degrees orientation. So now the tool can really machine this rotated part. So let's check it. Okay, I go to this particular operation because only this one have an updated tool orientation. I see the tool is rotated. I open the machine preview. Okay, it's calculated. And something is not works, okay, because maybe I didn't save my setup. So I want to rotate my part again. Yeah, it's saved. It's not saved. Okay. Say 30 degrees. Yeah. Now I will save and exit, and not just exit from it. Go back. Nope. the part is rotated. Okay, nice. Let's calculate everything. It's failed. Okay. Yeah, now part is rotated, and what you see here, the coordinate system is get its natural color. It means I can do it. Okay. And if I go to simulation, only this particular job, of course, okay, let's go it in machine simulation. Okay, machine simulation. Okay. And we can make it. If I go to G-code, I what expect to get here. Okay. So first, I get a message. Of course, I cannot use compensation in this kind of operation, okay, because my machine don't have a special plane rotation functionality. So I get a message. So I can go to technology, cancel compensation for this operation, and make a G-code again. And what I see here, the first, you see it immediately. I have a long toolpath. I mean, there is no arcs here. Everything is done by lines. Arcs is by short lines, and long lines by long lines. But there is no compensation, of course, and there is no plane. I mean, not call to G7 or G80 or 90 plane because it's not possible for it. So SolidCAM automatically recognized we cannot make arcs in this case, and we automatically split all the toolpaths to lines, okay, according to VMAD definition, the precision and everything, so you can adapt it for your needs. And you will automatically get G-code generated in lines. So this is very important fact what we get in SolidCAM. But this machine don't have a plane rotation command. Okay, but imagine you're doing the same on machine but can make a plane rotation for this particular phase. I can rotate my plane to this orientation. Okay, because if I open machine preview here, I also see this coordinate system, and I can go and show the position coordinate system. Where is it? And you will understand it looks different. Here the position coordinate system is normal to this phase. But if I go here, the z-axis is not only not normal, it's going up, completely different. Because your G-code, and it's a good reference for you if you're checking your G-code output or need to know what's the G-code reference for you, will be according to this coordinate system. Because the machine can define the position of coordinate system but cannot rotate it. You don't have a function like this. But if you do have something like this, okay, and it's easy to check it, you can go to machine and just change it to, okay, I have special command what can rotate the coordinate system around X. It can rotate the result coordinate system around Y and result one around Z. So now, okay, I have the reference, the machine can rotate coordinate systems. Okay, let's see how it will change the output of SolidCAM. So these are way to go here to this operation. And let's see what we have in machine preview. I go to machine preview, and what I see here, okay, the coordinate system is rotated according to the rules what we defined in coordinate in VMID. And now I can generate arcs. And if I will go and generate G-code, okay, okay, I see arcs exist here. Of course, some lines are empty, the post-processor not fit for a rotation of plane, but it do generate arcs. So everything is correct. Okay, so what we see now is what's the possibility for SolidCAM to generate a G-code for these operations. I will back set up to initial value. So I will put it to 0 degrees. Okay, I hope it will be safe. Okay, save it. I will exit. I also return the tool to initial position. I don't want to keep it like this. Okay, so let's put it on 0, save it, and recalculate everything. And I will cancel the plane tilting, okay, because my machine cannot tilt the plane. So I just put a null here, nothing can be tilted. And now I have an initial state. But additional parameter what we have, if your machine do not support arcs, even an ZY and XY, an XZ plane, what you can do, you can go to machine and go to controller definition and say, I don't want arcs in these planes. No, okay. And what will happen, we go to generate G-code for these operations, okay. You will get the G1 long G-code, okay. So if it's not a matter what machine you are working, we can cover any case of compensation of arcs of with cycles for drilling and everything for this kind of operations. Okay. So just for fun, let's see the simulation. Okay, in machine simulation for all part. See how it works. Of course, for 3-axis machines, most of our customers are not using simulations, machine simulator, okay? And if you are working with angular head attachment, I really recommend to work with machine simulation. It's much more safety, okay? So you can really see what happens on your machine and you understand how is dangerous it if you are not running machine simulation, how you are close to the limits and the fixtures you can and to other side of your part even. Okay, so it's okay. I guess we have time for maybe short demo of how we make this feature. Okay, I will not go here to the operation itself. I will go and define a tool for it. Okay, because this tool looks much more complex. Okay, but it's much more. It's not such complex, more complex than what we defined. So let's show how it works. I go again to the same website of OMG and take this tool, what can rotate generally in 2 directions, okay, and define this for me. Okay, so let's take a BT30, okay, and download both of them. I will unzip it in the second screen. Let's go and open the part. Okay, downloads. Okay. So we have this MS40. Okay. So the base looks the same, I guess. Okay, and we have the second side. Okay. The TV. I don't think this one is the correct one. Let's open this one. Yeah. This one is the correct one, is for bigger folder. Yeah, this one is correct. And let's open its second part. Okay. And how I did it before. Okay. Just go here. I will save it. Let's save it same place. Okay. Also save it same place. And I will make an assembly. Okay, assembly, it's easy part of SolidWorks. I guess everybody knows how to make it. Not. I just did a mistake. Now in it. Okay, so let's make let's take this one place and some.
Привет. Ну, как-то так, да.
Okay. And I will rotate it some reference position. Okay. Okay, I will do the same as I did previously. I will create a coordinate system. In the middle of folder. Okay. Of course, you can do it by old way. I mean, to define for each cutter, for each part, to save it as a STL file, and something is wrong here. Yeah. And, okay, but I prefer the wrong coordinate system. Sorry. I did something wrong. This is my X. This is my Y. Of course, you can play with it after and change it, but I prefer to get it directly from CAD as I want. I will hide it. Let's make here the new coordinate system. Okay. Whew. Why when I pick an X, it's don't want it. Okay. Let's reverse X. Okay. And the last one, we'll put it in the middle of rotation axis. So first, maybe we'll hide this component. Okay, and create some sketch inside. So take a plane, create a plane. Create some plane. Yes, it's correct place. And I will make here the coordinate system. Okay, let's project same axis. So in general, I did everything what I did previously. So I defined the components, I defined the coordinate system, playing with orientation and everything. So at the end of this procedure, I get all my components are and the coordinate system for each one. Okay, save it. Let's reedit the same the ToolKit, edit assembly. Let's go to these OMG attachments, and we already have here in advanced view the component. Okay, I will create a new one. Okay, and generate smearing tool. I'll be here the holder, attachment, the first axis and the second axis. Of course, it's not recognized perfectly. So this one, I want to the holder. Okay, this one now is the holder. This part, it's good. I will keep it as this. And the last one, I will change it to holder. So now I have three components inside. Okay, and I will exactly define the coordinate system. The first one, first coordinate system. Okay, this is second, and the third here, and convert it to SolidCAM tool. Okay, what I see now, okay, I see three components. What's the difference between this holder and the second one? First, let's define it as we have to define holders. I have a first component. Okay, let's go to its properties. Of course, you can change the color for it. So let's put something green. I don't know. It's changed, not changed, not important. And when I go to here, okay, I see the first component, and I go here, I see the second component. This one have a joint. The joint is here. What I want to do is the changes is joint, okay, to joint with rotary axis, okay. And I go to the joint to the axis data, and I say this axis is along Z. Okay. Now, if I go to the tool, I see the first axis. You see what happens? Okay, it rotates along the axis. After it, I'm going to the second component. I will say, make a joint, okay, set me as a rotor axis. And axis data, I will little bit, first it changes to X, okay, I will rotate out X. And what we will see here is not a perfect, okay, because it's rotate around some different rotation point. So I need to define the proper rotation point, and I'm doing it like I'm measuring, okay, the position of this coordinate system, this point, hard to catch it. No, okay, so I will just take this point relative to this third coordinate system, second, sorry. So it's minus the X value is not important for me. Important for me only the Z value is 37.5. Okay, so I will keep it and go back to this component, go to the axis data of the joint and set it minus the rotation point minus 37.5. Okay, now let's check if it's rotated correctly. No, it's not rotated correctly. Why? I did it for wrong axis, sorry. I can even check it here. No. Okay. Think I did some mistake during the creation of the model, and it's changed. So, now it's rotates good. Okay, so some my mistake. And now I have two rotary axes. The names is maybe changed. Like you can go and change the names of the axes just to be uh, to, to understand what you are doing. So first axis, let's define it as C because it's like C axis. It's around Z. And second, I will define it's like at a axis because around X. Okay, and save it. Now let's back to our CAM part. I will try to be short because the time is going to end, and I will go to the coordinate system. Of course, I guess you pay attention. It looks different than you are used to, but it's the subject for another webinar. Okay, and I just go and define here the coordinate system. So let's make it for rotation phase. Okay, it's good here. Need something special. And what I need to understand to make this feature is like the angle of this rotation. So I'm going to measure the angle between this face and this face. Okay, you can do it by measure function, and we see here is 135 degrees or 45 in other orientation. Okay, and I'm going to add a profile. Okay, operation. I will select this position number 4. Here is it. I will select the face what I want to feature what I want to machine. So let's make this one. Yeah. Just reverse it. Okay. I will take a tool, and here is started. I'm going to the same assemblies. Okay, OMG attachment. Now I have second item here. I will add it to my magazine. Okay, so first, because this attachment don't have a cutter, I can work here only in the mode of advanced mode. So in advanced mode, I can manage fixtures holders without cutters. Okay, so I'm going to make it. Oops. Put it here to the magazine. Yeah, and some values are rotated here, so I can cancel it. So now you see the component axis inside the fast access, okay, quick access. And I can understand what I have to do is to rotate it here 90 degrees. Yes, it's house mounted machine. And to rotate the A-axis minus 45. Okay, so the part is well mounted like this, and I can be here. Okay, if you want to be sure you are working in correct orientation, you just open the machine. Okay, you don't see the part once you are in a toolkit, but you can go to this holder and set it. Okay, mount it to the spindle. Okay, and you will see a tool is here. Okay, so yeah, the orientation of tool looks good. Okay, now I will add an end mill for this cut tool. Okay, and here is okay. Oops. Let's make it 80. Okay, and it's okay. Have a tool path. I open the machine preview. I see the coordinate system is having good colors. Okay, just to check myself, I'm going here again to the tool. Okay, I change the values of angle to 34 degrees. Okay, and I come back to the part. It's cool, this works. No, cool, it works. Maybe I didn't save it. Let's make hmm. Okay, forget about it. It's a DV version. And so let's check it again. I will put 45 degrees in quick assess. Okay. And let's see in a machine simulation. First of all, let's see how it works in G-code. I'm going to G-code. Of course, compensation is not possible, so let's cancel the G-code generation. Okay, it can't work here. Okay, cancel the compensation. I expect to get G-code split into lines. Yeah, perfect. I get it. And of course, if I run the machine simulation, okay, I'll see the holder is oriented perfectly and everything is cut as we are want. Okay. So in one hand, it took me about 1 hour to show you how it works. Okay. And you will say, okay, it takes too much time to define it, but not. I guess on your factory, you don't have like 25 kinds of angular heads. You have maybe 5. And to define 5 angular heads, not for presentation, it takes maybe 15 minutes for 10 minutes for each one. And you spend 1 hour and you have a collection of angular heads because each holder I defined now can be used for other parts. Okay, I still didn't show some parameters how to define the ratio, how to define the CW, CCW because we are limited in time. But of course, everybody of you can make this assembly of angular head for your machine and use it for your parts cutting and save a lot of time and complex fixtures and also simulate it in machine simulation if you have to understand what's going on the machine. And if you don't have, you have a machine preview, you can estimate what happens. And of course, you have we have support for any kind of controller and kind of G-code what you want to get and any machine what you want to run with angular head can run with angular head. So thank you. If you have questions, okay, I don't get a list of questions here, okay, but if nope, I don't. I have a question how to use TWP in Fanuc. I don't exactly know what we are talking about because maybe the terminology. I guess you are talking about the plane rotation function. So Fanuc have several different machines and several different options to rotate the plane. You can use Euler angle, you can use spatial angles, you can use single angle like for turning machines or mill-turn machines. It's very dependent. And if you define it as it's wrote in your book, so for example, if you work on Mazak machine, you will define it as single angle. Or if you work on Fanuc head machine, it's always will be 3-axis or Euler angle. You have to know exact what's the rules on the machine, how to define the tilt plane. And so it can support any rotation what can be possible defined. So you go to VMID, and in VMID we have, of course, it's not for customers, it's for just who have to do it as a post writer, because he have all the knowledge. Okay, but if you are a customer or you are just want to know how it works, I just show it's possible. In SolidCAM we have the rotation type is how the tilt plane is defined for the machine, and TCP his works. And here you can define any possible combination of axis order what can be defined on the machine. Or use the kinematic axis. If your machine running Euler angle, so you can, for example, define it's like Z, X tag, and Z tags, okay? And it will be Euler angle, or any other, okay? If you are using kinematic axis, okay, we will automatically calculate the order according to machine kinematic. So any possible combination you can be defined in SolidCAM, and we will get output according to this combination. Just the post writer have to adjust your post processor and to work with this particular plane transformation. So thank you for the question. Okay. Okay. The second question is it possible to use heads with axis driven by G-code and not manually ones? Yes, it's possible, but currently we are not support automatic exchange of heads. We do have a functionality what we are implementing in SolidCAM with like a hidden heads and machine simulation, and so if you don't have like a head, but a lot of different types of heads on your machine, we can support it. We can define exchange the head and show it in simulation, okay? And of course to get a G-code. So, but it's not supported in ToolKit. So what I showed today is like less complex, and it's how you to use it on machine what is completely don't have any kinematic or G-code controlled axis. What you're asking is like to exchange the head and control B and A axis or whatever you have there, and kinematically and make it 5-axis toolpath or indexal 5-axis toolpath. Of course, it's supported, but it's have to be defined by other procedure and not by ToolKit. It's defined in VMID, and you can define in machine simulation the geometries for it and everything. So we do have customers who work like it. Okay, so we can refer to Daniel Jurica. He's our support manager, and he will maybe show you the example for it. Okay, but it's a little bit different subject. Okay. Okay, I think we are done, and people pretty tired. So thank you very much. Okay, and meet you in next one. So next one, I don't know who will do it, but stay tuned. It's always better than my. Thank you very much.